Okay, let's try this again. The first time I recorded this, I didn't have the microphone on, so hopefully this works this time. All right, we're going to solve quadratic inequalities, and the main difference between a quadratic equation solving and quadratic inequality is an equation has an equals, and you get two answers, and an inequality has inequality signs like greater than or less than, greater than or equal to, less than or equal to. And so within inequalities, you have a range of answers. So the main difference is that you have the range of answers versus the just two answers with the quadratic inequality. We're going to use the number line to help us find that range of answers. So when we graph on the number line, remember that if you have a greater than or less than, you'll have an open circle. And if you have a greater than or equal to or less than or equal to, we'll graph that with the closed circle to represent the difference between those inequality symbols. So here we go. Remember, we do have multiple different methods that we could use to solve this quadratic inequality. We could use the quadratic formula, completing the square, factoring. I think that we're going to stick to factoring since this one does factor. It's just x squared, so I know it's going to be x times x. So I just need to figure out what multiplies to 6 but adds up to -5. So we have -2 times -3 would multiply to 6 and add up to -5. So my factors are x minus 2 and x minus 3. And just like when we solved by factoring, to figure out what x equals, we set each of those factors equal to 0 and solve for x. And we can go ahead and throw that on a number line. And the number line is going to help us decide what the range of values that this is going to take on. What are my x's equal to? So I have a greater than or equal to sign in my original, so I'm going to have two closed circles. One closed circle at 2 and one closed circle at 3. Now I have two options. Either when solving a quadratic equation, you're either going to have two types of solution sets. You're going to have two values. Let's say that this is A and this is B. You're either going to have your x's that are between A and B. You're going to say that x is greater than A and x is less than or equal to B. That's one option. Or you're going to have A and you're going to have B, and your x's are going to be less than or equal to A, or your x's will be greater than or equal to B. So we have two separate solution sets here. You can either have your x's between the two values, between your two answers, or you can have them to the left and to the right. So we'll need to decide which situation we have over here. And to do that, I like to choose a point and just test it to see if it's true. So I'm going to choose the point in between 2 and 3, and I'm going to choose 2.5. And you can either plug that back into the original equation here, or you can plug it back into the factored equation, because this also would be greater than or equal to 0. I think in this case it would be easier to plug it back into the factored. So I'm going to plug that back in for x. So 2.5 minus 2 times 2.5 minus 3. Is that going to be greater than or equal to 0? That's the question. So here I'm going to get 0.5. Here I get -0.5. Is that greater than or equal to 0? Well, 0.5 times 0.5 is -0.25, which is not greater than or equal to 0. So since this point, 2.5, is not a solution to our original equation here, that means that our solutions are the x's that are less than or equal to 2 or greater than or equal to 2. So our final answer will be written like this. These represent my x's, all values of x. So my final answer is going to be x is less than or equal to 2, or x is greater than or equal to 3. All right, let's go on to the next example. Okay, again, this one factors, so that's the method I'm going to choose to solve it. It's an x squared, so I can find factors of 5 that add up to -6, and that's going to be -1 and -5. So it's going to factor to x minus 1 and x minus 5 less than or equal to 0. So solving for x here, I'm going to get x equals 1. Solving for x in this one, I'm going to get x equals 5. So had this been an equation versus an inequality, I would be done solving this. These would be my answers. I would have 2 answers and that's it. But since it's an inequality, this quadratic equation is less than or equal to 0. That means I'm going to have a range of values that x could be. So if I threw 1 and 5 on the number line, it's going to help me decide where that range of values is going to be. Again, we're going to have closed circles because of the greater than, or I mean the less than or equal to sign. So my circles are going to be closed at 1 and 5. And then I need to test a point to decide which way I'm going to draw the line. Is it going to be between 1 and 5, or is it going to be less than 1 and greater than 5? So here I'm going to test, you could test 3 again in the middle. I'm going to actually plug in 0 and go back to the original. Plug in 0, 0 squared minus 6 times 0 plus 5, is that less than or equal to 0? Well, is 5, 0 plus 5 less than or equal to 0? That's not true. So the 0 is not a solution here. If I plugged in 3, now I know just by testing 0, since 0 is not a solution, I know that my x's are going to have to be between 1 and 5. But just to maybe verify that, I could plug in 3. Maybe I want to use the factored form then to plug in 3 because it'd be easier. So 3 minus 1, 3 minus 5, is that less than or equal to 0? That's 2 and times -2. So that's -4 less than or equal to 0. That's true. So that means that 3 is in fact a solution. So we are between 1 and 5. So we can write that as a compound inequality. We can either write that as an and statement or a compound inequality. As a compound inequality, I could say that x is between 1 and 5. X is less than or equal to 5, but it's greater than or equal to 1. Notice that if I read this from left to right, 1 is less than or equal to 5, and the inequalities always face the same direction and they always point at the smaller number. You could write that as x greater than or equal to 1 and just with the word and x is less than or equal to 5. So that's an alternate way of writing it if the compound inequality is confusing. And I'm going to do one more example here. I'm going to do one that has an open circle when we graph, just so you see the difference. And then also this one's not equal to 0 right now, so similar to when you solve, it does have to be equal to 0, so you'll have to subtract 3 on both sides first. So you get 2x squared minus x minus 3 greater than 0. Now this one is factorable, but it requires a little bit more work. And you can factor it whatever method you would like. So the 2x squared here and the -3 here, this is essentially AC, similar to AC split. You take the product of A times C, which would be -6, and you want that two numbers that multiply to -6 but add up to B, which is -1. So two numbers that multiply to 6, -6, but add up to 1, that's going to be -3 and +2. So you get -3x and 2x go in the diagonals of your box, and then you figure out the outside of the box. So I would start with the 2x squared here. You could either do 2x times 1x, and that's it. And so the 2x has to go up here since I have a 2x here. So I'm going to have 2x times x. Then x times what equals negative 3x? That'd be negative 3. Then, 2x times what equals 2x? Well, that's 1. So it factors to 2x minus 3 and x plus 1. So solving those, you set 2x minus 3 equal to 0. I'm going to have to add 3 to both sides. Then I will have to divide by 2. So x equals 3/2. Go over a little bit more here. X plus 1 equals 0, so x equals negative 1. Again, if we were solving the quadratic equation, we'd be done. Those would be our answers. But this is an inequality, so we're going to need to see what the range of our values are going to be. So we'll do our number line up here. We have to go from negative 1 to 3/2. Note that that is the same thing as 1.5 if that's easier. We got negative 1, 0, 1, 2. So this time we're going to have open circles since it's just greater than. So an open circle at negative 1 and an open circle at 1.5. And then anytime we do have the opportunity to plug in 0, it's a good choice because it's easy to plug in 0. So I can choose 0 here in the middle and see if it's a solution to this inequality. So go back to the original, and 2 times 0 squared is 0, minus 0 is 0. Well, is 0 greater than 3? That's not true. That means that our inequality goes this way and this way. 0 is not a solution. So our final answer would be written like this. Let's see if I have some space here. It would be written as x. It's going to just be less than, because it's an open circle, less than negative 1, or x greater than 3/2, open circle. So that's our final answer then. Because it's an or, because it's facing out. If it was facing in together, then that's when we would do the and or the compound inequality. So this is an and this way is an or. Okay, hopefully that was helpful if you missed notes today, or if you just needed a quick refresher of what we talked about when we took notes in class. Let me know how it goes. Thanks.